Hey guys, so today we'll be discussing Introduction to Java Collections Data Structures. So the topics today are Introduction to the Java Collections Framework, JCF, lists, sets, maps, and the collection and list interfaces, the iterator and list iterator interfaces, and array lists. So we're just looking at some of them right now, and we'll look at the rest of them later. So it's just like an introductory. But we are working with lists, and we'll be working with, array lists we've worked with, and then we'll be working with array lists, and some stacks, which we already talked about, but we'll talk about sets and maps later. So the Java Collections Framework. The Java Collections Framework, JCF, is a library of classes and interfaces for working with collections of objects. A collection is an object which can store other elements. A collection is an object which can store other objects, called elements. Collections provide methods for adding and removing elements and for searching for a particular element within the collection. There are three main types of collections in the Java Collections Framework: lists, sets, and maps. List-type collections assign an integer called an index to each element stored. Indexes of elements are 0 for the element of the start of the list, 1 for the next element, and so on, just like arrays. Lists permit duplicate elements, which are distinguished by their position in the list. Unlike arrays, lists are usually not declared with a size. Instead, they can grow as needed. Sets. A set is a collection with no notion of position within the collection for stored elements. Sets do not permit duplicate elements, since there is no index to differentiate one from another. Maps. A map is a collection of pairs of objects. 1. A value. This is the object to be stored. And 2. A key. This is another object associated with the value and which can be used to quickly find the value within the collection. A map is really a set of keys, with each key having a value attached to it. Maps do not allow duplicate keys. So the example below is part of the Java Collections Framework hierarchy. So we have an interface, the interface collection, that's at the top of the hierarchy. So abstract collection extends that collection. So interface list and interface set both implement the collection, not extend. So then we also have the interface starter set, and you can see we have all these different ones. This is just part of it. So abstract list, abstract set, abstract sequentials list, linked list, array list, vector, hash set, tree set, linked hash set. So we're going to go, eventually we'll have covered all of them. Right now we're just doing array lists, a little bit of lists, but you'll see the rest of them later. So the collection interface. Lists and sets are similar in many ways. The collection interface describes the operations that are common to both. Maps are fundamentally different from lists and sets and are described by a different interface. We will cover them in the main data structure series. Sorry, it's a typo. So methods in the collection interface. Add. Takes a parameter obj, which is of type E. It returns a boolean, and it adds the object obj to the collection. The method returns true if obj is successfully added to the collection and false otherwise. So clear. The method clear, it has a void return type. It removes all the elements from the collection. We've gone over add and clear in the example codes and some of the rest of them. Contains, it takes an OBJ as a parameter of type object. So it returns an object. So it contains, it takes an object as a parameter and it returns a boolean. So it returns true if obj is an element of the collection and false otherwise. The method is empty. It returns a boolean and it returns true if there are no elements in the collection and false otherwise. So iterator. The iterator method takes no parameters, but it returns an iterator of type element E. Returns an object called an iterator that can be used to examine all elements stored in the collection. The method remove, it takes an object as a parameter and returns a boolean. It removes the object obj from the collection and returns true if successful and false otherwise. Size. It returns an int, returns the number of elements currently stored in the collection. Iterators. An iterator is an object that is associated with the collection that provides methods for fetching the elements for the collection one at a time. Iterators also have a method for removing from the collection the last item fetched. Iterators implement the iterator interface. So it should be up here. Iterator, is it up here? No. Alright, sorry about that, it's not up there. If you want to see the diagram for it, just look on the Oracle docs, on the API documentation. So where were we? Okay, so here, methods of the iterator interface. So has next, we've worked with that before. Returns a boolean. So it returns true if there is at least one more element from the collection that can be returned, false otherwise. So next, we've also worked with that. So it returns an element of type E, a generic type. So it returns the next element from the collection. The method remove returns a void. So you'll see some of the same ones in all of them, like are similar. So remove, it's returns a void. So removes from the collection the elements returned by the last call to next. This method can be called at least one time for each call to next. Iterator example, using an iterator to fetch and print all elements in a list of strings. Okay, so should be a space here. So here's an example. Okay, so here's an example. It's an iterator example, and we're using an iterator to fetch and print all elements in a list of strings. So we have a list. It's polymorphic, so it's created with a list. So it's really an array list, but we're creating it with a list. So list of type string objects, or list of type string object called names is equal to new array list. So we've created a new array list that's polymorphic, and we've called the add method, and we've added some names. So names, we've called our array list name names, and we've used a dot operator to access the add method, from which we've added a string, which is a name. The name's Anna. Then we've also done the same thing again. We've added Bob as the string for the name, and then we've also done it again. So we've called names.add. We've added Carlos into the array list. So if you're wondering why it's a string because it's in those quotations. If it's just in a single quotation, then it's a character, and if it's just nothing, then it could be some kind of number like an integer float or something like that. So then we've created an iterator. So iterator, and then of type string object named it is set equal to names. So we've called our array list named names. We've used the dot operator to access iterator, the iterator method. So it gets the iterator. And then we've created a while loop. So we said while it, our iterator, has next, so it has a name to pass to us. String name is set, I think it's supposed to be equal sign, is set equal to, oh it is, is set equal to it dot next. So the string name, so we've declared a variable here called string name, and we've set that name equal to whatever our iterator is going to pass to us with it dot next. Then we system.out.println, so we printed out the name. And I just put the bracket here to save some space. We could just put it down there. So instead of the while loop, we can use an enhanced for loop. So we could have said for string names. So for string name is equal to names, system.out.println the name. So all this is saying is for we're creating a string named name, and this is like something they use in the ternary operator, but I just say to myself equals. It just helps me remember. So I just say so string name is equal to our array list named names, then print out the name. It's pretty simple. It's kind of hard to understand at first, but it helps. It's easier than writing a for loop all the time, but sometimes if you like for loops, they could help too, but I guess we didn't use one here, but that's okay. So the iterator remove method, the remove method removes the element returned by the last call to next. The remove method can be called at most one time for each call to next. The list interface. The list interface extends the collection interface by adding operations that are specific to the position-based index-oriented nature of the list. The methods in the list interface describe operations for adding elements and removing elements from the list based on the index of the element. There are also methods for determining the index of an element in the list when the value of an element is known. So there are also methods for determining the index of an element in the list when the value of an element is known. So here's some of the list interface methods. So we have add. So it's method add. So it takes an index, which is an int, also an object of type E, element E. It returns a void and it adds the element object to the collection at the given index. So we've seen this add, it's just written differently. So get, the get method, it takes an index it takes an index element of type int as a parameter, and it returns an element of type E, generic type. So it returns the element at the given index. We've used these in the Arraylist example, so see that if you want to learn about those. So index of, it takes an object obj as a parameter and returns an int. It returns the least first index at which the object obj is found, returns -1 if obj is not in the list. Last index of takes a parameter of type object, obj, and it returns an int. It returns the greatest last index at which the object is found. Returns -1 if obj is not in the list. So list iterator. It returns list iterator, so no parameters, and it returns list iterator of type element E, generic type. Returns an iterator specialized to work with the list collections. And then we have the remove method. So the remove takes an int named and takes an int, could be called index, and it returns an element of type E, generic type. Removes and returns the element at the given index. So then the set method takes two parameters, so an int and then so an int could be called index, and it takes a type E element, could be called obj, and returns an element of type E. Replaces the element at index with the new element object. So obj is short for object. So now we're at Arraylists. An array-based list internally, it uses an array to store its elements. Whenever the array gets full, a new, bigger array is automatically created and the elements are copied to the new array. The concrete class Arraylist implements the list interface. So you can use list interface references to instantiate and refer to a concrete array list. That's what we did above in the polymorphic example. So using a list interface instead of a concrete class reference allows you to later switch to a different concrete class to get better performance. So an example. So it's the same thing here. So we call the list class, and then the list class of type string objects. We want to hold string objects in that list. We call it name list, and we've set it equal to new array list of string objects. So it's the same thing, right? If you just wanted to do array list here, it's the same thing, but they're just saying you can use it differently a little bit. So we've also created an array here. So string array name names is set equal to, and it's setting up the elements here, just writing them out. So we've set it to Anne, Bob, and Carol in quotations. So these are three strings and their names, and we're holding it in the array, the string array names. So then we have a for loop here. So for in k is equal to 0. So it's starting at the beginning. The first index is 0. K is less than names.length, k++. Names, namelist.add, names of k, of array k. So we basically it's just adding from the array to the array list. So we're saying name list. Where's name list? So name list. Sorry, no. Yes. Name list.add. So name list is here. Names of k. So add everything that we iterate through in this for loop. So 0, it's going to add Anne. Then it's going to plus 1. 1. So 0 is Anne, 1 is Bob, 2 is Carol. So it's going to start at 0, it's going to add Anne. It's going to increment by 1. Then we're at 1, then it's going to add Bob. Then it's going to increment by 1. Then we're at index 2, then it's going to add Carol. And then that's less than length, so 1, 2, 3. Yeah, so now it's at below 3, less than 3. So it's going to stop. And then there's another for loop here. So for in k equals to 0. So we're starting at the beginning. The 0th index. K is less than name list. So that's our array list dot size. So the size of our array list now is whatever we just added, so 3, and then k++, and then we're now going to retrieve those elements with the get method, so system.out.println name list.get k, so it's just going to get everything from that array list and just print it out. Okay, so the list iterator interface. The list iterator extends iterator by adding methods for moving backward through the list in addition to the methods for moving forward that are provided by iterator. Excuse me. So example, has previous, and then previous. So some list iterator methods, I think we've gone through some of them, so I'll just skip it, but if you want to have a look at them, that's okay. Maybe just pause the video. Okay, so Iterator Positions. Can think of an iterator as having a cursor position. It starts just before the element that will be returned by the first call to next. A call to next puts the cursor just after the element return, and just before the element that will be returned by another next. At any time in a list iterator interface, at any time in a list iterator, the cursor is in between two list elements. A call to previous method will skip backwards and return the element just skip. A call to next will skip forward and return the element just skip. So here's here's iterator and list iterator exceptions. So a call to previous throws a no such element exception when there is no element that can be skipped in a backwards move. A call to next method throws a no such element exception when there is no element that can be skipped in a forward move. So example, we're creating another array list here using list, so it's kind of like polymorphic. So list holding string objects named name list is set equal to new array list that's holding string objects. So then we've again created an array of type string, so string array, and we've called it names. We've set that equal to some string object, so we got Anne, Bob, and Carol the same in the array. And it just does the same thing pretty much we just did above, except it uses an iterator. So adds to the array list using a list iterator. List iterator holding string objects named it is equal to names list dot list iterator. So for int k is equal to 0, names, which one's names? Okay, so we're looking at our array right now. So for int, using a for loop, so for int is equal to 0, so it's starting at the 0th element. It's saying k is less than names.length. So it's less than 3, k++, so it's going to iterate through the for loop. It's going to start with Anne, it's going to go to Bob, it's going to go to Carol, then it's going to stop. So add names, so it's going to add all those names, and then get a new list iterator for printing. So it's saying it, we set that equal to namelist.list iterator. Then it says while it has next, print out it.next. So it just iterates through this with an iterator and just prints it all out. So that's just an introduction to collections and data structures. So I hope that helps, and I'll see you guys later. Take care.